This lesson is on how to calculate the Pearson Correlation Coefficient. It's quite a large formula. The Pearson Correlation Coefficient is denoted by the letter R. Okay, so you have a large formula, R equals, and you have this large denominator, n, summation of x times y minus summation of x, summation of y, all over massive square root, and then you have two sets of brackets that involves the x's and y's and summations of different forms. The best thing to do is to let a table do all the work for you. Please note that R value can only be between 1 and -1. If it is perfect 1, this is a perfectly linear positive relationship. If it's -1, then it's a perfectly negative relationship, linear relationship. R tells you the strength of the linear relationship. Okay, and it can be between 1 and -1. If it's somewhere around 0, it's extremely weak. It's no relationship at all. If it's under 0.3, it's considered very weak. If it's between 0.3 and 0.67, it's moderate. If it's greater than 0.67, it is considered very strong. So if I take some x and y values, again, I'm going to let my table do the work for me. Look at the formula of what you need to have. You need to have a column of x's and y's multiplied together. So I'll create that in my table. I'll do x and y multiplied together. Then I need to have an x squared down here. I need to have the same thing for y squared. So I'll have a column of x squared, and then I'll have a column of y squared. And I'll let the table do the work. So I'm going to do x times y, 1 times 2. Okay, that is 2. 3 times 4, 12, 5 times 6 is 30, and 7 times 8 is 56. Then I'll do my x squareds. 1 squared 1, 3 squared 9, 25, 49. I'll do my y squareds. 4, 16, 36, 64. Then it's going to ask me, in the formula, it asks me to sum up these different components. I need a summation of my x, summation of my y, sum my xy, same thing with my x squareds. Okay, and y squareds. So at the bottom, I'll do a summation, and I'll start adding these all up. So I'm going to get 16 here. I'm going to get 20 for summation of y. Add these up here. So I want to have 14. I want to have 44. I'll have that will give me 100. Okay. Then I'm going to have, let's see, 10, 35. So I want to have 35, and I'll have 84. And then again here, I want to add these up. So I want to have 20, 56, 56. That's going to give me 120. Okay, so I add them all up. Now I can put things into my formula. I should also note that in the formula that asks for an n, I have 4 sets of points, x and y, 4 sets of coordinates that will be creating my scatter plot for different points. So my n is going to equal 4. So I'll put these into a formula. So I have R equals, and I might as well rewrite my formula on another piece of paper. R equals n summation xy minus summation of x summation of y all over large square root. I'm going to have first set of brackets n summation of x squared minus summation of x bracket squared. And I'm going to have n summation of y squared minus the summation of y bracket squared. Okay, so I can start putting in the values from my table. My n value is 4. My summation of xy that I found in the table was 100, minus my summation of x, which was 16, and my summation of y, which is 20. Okay, then I'm going to have my n again being 4. Summation of x squared was 84, minus the summation of x, which is 16, and that value need to be squared. Do the same thing with my y, so my n was 4, my summation of y squared was 120, minus the summation of y, which is 20, and I want to square that. Okay, so then I want to have, let's see here, I want to have 400 minus, and then I want to have 16 times 20, 16 times 20, which is 320. Okay, all over 4 times 84, which is 336, subtract 16 squared, which is 256. That's all in brackets. Another set of brackets of 4 times 120, which is 480, minus 20 squared, which is 400. So 400 minus 320 is 80 over, then I have 336, subtract 256, which is 80. I forgot I need to have the square root on the entire denominator. Square root on the entire denominator. Square root on the entire denominator. And I have 480 minus 400, which is another 80. Okay, so I have 80 over the square root of 80 times 80. 80 times 80 is 6,400. The square root of that is 80. Square root of 6,400 is 80. 80 divided by 80 is 1. So I end up with an R value of 1, which meant that my X and Y values I gave were a perfect positive linear relationship. Okay? So it's quite a large formula. The numbers for the formula came from the table, and I let then just a matter of using the formula and putting it in and actually just calculating it. So again, the table did the work for me, and just make sure you keep everything in order. It's a massive square root on the bottom of the entire denominator, so make sure you remember that. This is the Pearson Correlation Coefficient, brought to you by Energized Math.